Okay, good morning, guys. We're going to go over a little bit about the distributive property now that you did a bunch of practice problems on Friday and Monday. And yes, there were a lot, and I was hoping, and I think a lot of you did, some on Friday and some on Monday. I really want you guys to get the distributive property down. So the more you do it, the better, and there's just so many different types of problems and so many different situations with negative numbers. That's what I wanted you to practice. I gave you mostly all subtraction ones, if you noticed. There was just maybe 2 addition problems because the subtraction ones are the hardest. So I just picked a couple to go over. I think I have like 4 from the homework that I wanted to go over. And then I want to practice kind of going backwards. So anyway, just hang with me here. So this was number 5. You've got a -4 that needs to be distributed to both factors inside your parentheses. It needs to be, the x needs to be multiplied by -4 and the 7 needs to be multiplied by -4. Now, when I look at that, I think it's a -7 in my mind. But then I realized, okay, I don't think I've ever really explained it to you guys that way. It's just -7. How is it a -7? Well, remember when we talked about subtracting integers and we were learning all about positive and negative numbers, we said that anytime you're subtracting an integer, it's the same as adding the opposite. Okay, I promise you it's in your notes. We add the opposite, or keep, change. There's a couple of different things, but adding the opposite really is the best way to remember. So if I think about this, this is like saying adding, and then the opposite of a +7 is a -7. So when you see -7, it's the same as saying adding a -7. If you need to change it to add a -7 to help you keep your signs straight, I recommend you do that. But I've just done this so long, when I see that -7, I just think -7. So let me show you why the answer, and one of the options for the answers was to come out positive. I'm going to work it both ways. So now I do and a lot of you guys, if you skip the writing out the steps, it makes it harder to get it correct also. So the first thing I need to do is multiply my -4 times my x. Okay, I just changed this to an addition problem. I'm going to show you both ways, so don't change this if you did it differently in your homework. Then I'm going to do the -4 times my -7. Okay, so now I have -4x, and I don't need the dot there because remember, -4x means -4 times x, plus a -4 times a -7. A negative times a negative is a positive, so my answer is just a positive 28. Now, a lot of you guys did it. That's one way to do it. A lot of you guys didn't change this. Most of you didn't, because I didn't really tell you you needed to. And you left it as like that. That's fine. Let me do that. Okay? So if you leave it like this, you're still going to end up with -4x. But then you're going to have minus a -4 times a +7 is a -28. Okay? And when we were subtracting negative numbers back, I want to touch my face a lot. I'm not supposed to do that. This is the same as adding the opposite. So again, it's add the opposite. And you can leave it as minus a -28. That's totally fine. But the best way to write it really is 4x plus 28. But this is not wrong. If you left it as minus -28, that's fine. You're just going to... it means the same thing, because minus -28 means you add 28 if you were going to solve it. If I gave you like a value for x and you were going to solve this, you would eventually end up adding 28. I don't know if that makes sense. So let's try this one. Number 6. First thing I'm going to do is multiply -6 times -x. Now, one of the other things that I forgot to talk about last week is when you have negative in front of an x, there is an invisible 1 right here, because you have at least one x or there would be no x there. If I put a 2 in front of it, then you have 2 times x. If it's just x by itself, it's just 1 times x. So anytime you see -x, -a, -b, -z, whatever the variable is, there's an invisible -1 in front of it. Okay, so -6 okay, times a negative, I'm just going to leave it as a negative x because I know it's a 1, minus negative 6, and I'll go ahead and leave it minus, so I won't change it to addition yet, times 2. Okay, so now I'm going to go a negative times a negative gives me a positive. So this just becomes 6x minus a negative times a positive is a negative, and I have a negative 12, right? So I said this was one of the possible answers. This is for number 10, right? Yes. Or I like to really simplify this and just say 6x minus a negative 12 is saying the same as adding the opposite. You could use a different color here to show you. Remember when we were learning this back in the fall? We were saying if you're subtracting a negative, you're taking away the negativity, so it makes things positive. That was just a silly little phrase we were trying to help us remember. If I'm subtracting negativity, if I'm taking away negative, that means I'm making things more positive because I'm taking away the negative comments or the negative attitude, and I'm making things more positive. So kind of just like a life quote to help you remember, if I'm subtracting the negative, I'm taking away negative, and things are going to be more positive. So just a silly little way to help you remember that this and this is exactly the same value. Okay, let's do 2 more. So let's look at number 14 next in your homework. Okay, this was another one where it was just weird on the worksheet, and before I scanned it, I should have went ahead and put the parentheses around the number 11, but it was in the directions, and hopefully everybody read the directions. But the number can be behind the value that you're multiplying by can be after the parentheses. So this just means I'm going to take the x and multiply it by negative 11, and I'm going to take the 4 and multiply it by negative 11. So the first thing I'm going to do is negative 11 times x minus negative 11 times 4. Okay. Just writing out this again, it just becomes negative 11x minus a negative times a positive is a negative, so it's negative 44. And then you can change that. This is an acceptable answer. If you left it like that, that's totally fine, but I'm going to change it because I think in algebraically that just really is the better answer. Again, it's not wrong if you did that, but I wanted you guys to see why this was also an answer choice, because I didn't address it in the videos, and I know it was coming up for a lot of you on your homework. Okay, last one. Got an extra negative here. Again, here's that invisible 1 in front of the x. So I'm going to do negative 13 times a negative x, and then a negative 13 times the 3. So I'm going to write it out. Negative 13 times a negative x minus, remember there's that minus sign, a negative 13, times a 3. Okay, so now a negative 13 times a positive, if this was a 1, a negative times a negative is a positive, right? So this just becomes 13x. Okay, it's positive. Oh, I realize I made a mistake in my answer key. I forgot to bring the 1 down. That's okay. Minus a negative 13 times 3. A negative times a positive is a negative, so you end up with negative 39. Okay, if you left it like that, that's totally fine. But I'm going to go ahead and say, but I know that this is really adding the opposite. So really what I'm doing is this, because if Miss Offutt were to tell me later that x was equal to 2 and I had to solve it, I would end up having to add 39. So that's why it's always good to take it to this simplified form, because if you do end up being given the value for one of those variables, you're going to need to change this to solve it. Okay, so hopefully that just explains some of the confusion as you guys were working some of the homework. If you missed some of these, it was just a practice, it was just a completion grade. Distributive property is pretty tricky. So the last thing I wanted to show you, and if you want to, you can pause this real quick and grab your math spiral, or you can just add this to the homework questions. I showed maybe one of these in the homework and not in the homework, in the lesson video last week, but you're going to see a little bit more of this. So I want you to be aware of it. So we talked about last week in our notes. Let me see if I can, what did I just do? in our notes. Let's see here. I don't know what Ms. Alpha did with her notes. Wait a minute. They're here. I promise. Okay, so we would start out in this form, then we would take it to expanded form, and then we would evaluate it and come up with an answer, right? Right. So what I want to say is if we're in expanded form, how do we go back to this form, this original form? So I want to address that really quick. We're going to call this form the simplified form because we've done everything we can to this. We can't do anything else unless somebody tells us what X is. Right now it's simplified. So how do I get it into expanded form is what we need to talk about next. So I have to think about is there a number that both 3x and 6 have in common? Is there like a greatest common factor to both of these numbers, or a number they both have in common? And I want to go with the largest one. Okay, so I know 3 goes into both, right? 3 goes into 3 once, and 3 goes into 6 twice. So I'm going to get a different color here. So if I think about that, I can say, okay, if I divide both of these by 3, right, then what would I end up with? I would end up with x, because 3 divided by 3 is 1x, but I don't need the 1, plus 2, right? So I divided both of these by 3 to get x plus 2. So if I want to go back to 3x plus 6, I probably need to multiply these by 3 because I need to do the opposite. Okay, I need to, you're kind of redistributing. Remember the distributive property, if I had 3 times x plus 2, you're distributing the 3 to the x and the 3 to the 2. But now I want to work backwards and kind of like redistribute or undistribute. It's not really a very good word. Go backwards, and I want to take out a common factor from both of these values and simplify them. And then whatever, if I divided, then to go back to it, I need to multiply. So I don't know if I'm explaining that very well. So let's try another one. Let's see. What if I did 2x minus 4? Okay, 2x minus 4. What number do both of these have in common? Well, they both have 2 in common. So I would need to divide both of these by 2 to get it to simplify it. 2 divided by 2 is 1, but I don't need to write a 1x. I can just put x. There's an invisible 1 there. Minus 4 divided by 2 is 2. And so did I do it right? Well, let's check. Since I divided to get this, to go back to 2x minus 4, I would need to multiply by 2. Would that be correct? Let's see. 2 times x is 2x minus 2 times 2 is 4. And that takes it. So you can go back and forth. But sometimes you're starting out with the more simplified form, and you need to go to an expanded form. Okay, so that's kind of, you'll see math problems that are asking you to go back out to the expanded form. This would be more of the expanded form. From the simplified form to that original factor form. Not expanded, sorry. Yeah. There'll be more of these. I just wanted to show you this. And as we do the lesson today, the new material today, this is probably going to come up again. But just be aware that there's ways to go backwards. That's really not the best term to use, but to kind of redistribute the numbers and go back from a simplified form to an original form. Okay, that's enough on this. Hope you did well on your homework, and hopefully we answered any questions you had about your homework. If there's something on your homework that you still didn't understand, leave a comment below, and I will try to address that with you and help you out. All right, take a little break, and then we're going to learn something new in the next activity. All right, see you back.